So welcome to Lesson 3, Incremental Values and Timed Values Activity. This is Unit 2, Module 2, Lesson 3. I would like you to go into App Inventor to start and create an app called Incremental Values and Timed Values. Pause the video right here so you can see the title until you have that done, and then continue. Okay, so let's dive in. So we've looked at this code before, where we have a canvas drag command, we have the canvas touch command, we have the dot size. We looked at that command, all those commands before. It's what we did last time. This time what we're going to do is we're going to start by creating a really silly little game. And we're going to kind of build on this game as we go. And the game is pretty simple. Every time the user clicks the button, they get a point. Nice and simple, right? So to score a point, they press the button, the counter goes up. To do this, you're going to create a button, call it button 1 for now. Create a score label. So you're going to have to create a label, call it score label. Set the text to score label.text plus 1. So what we're doing is we're incrementing the label one time every time someone presses the button. So if they click the button, it changes to 2, and so forth. So I want you to start by doing that, pause the video, and then we'll move forward. So if you go to the user interface and you scroll down to label, this is the label that you want to use for the score updater. So some interesting things happen here. This is a text. So something interesting is happening here. The 0 is technically text. It's not really a number. So if you didn't change this to a 0 and left it as a word, whatever it said, I think it said something like text box or text information, whatever they had in there, and started adding 1 to it, App Inventor would just string the ones right after each other. So it'd be text 1, text 1, text 1. So it'd be text 1, 1, 1, 1, 1, 1, 1, 1, 1. Every time you hit the button, it would just concat or put another 1 at the end there. By making this a 0, App Inventor is smart enough to say, okay, well, since this is actually a number, it's not really text, it's a number, we're going to treat this plus sign, instead of being the concat operation, we're going to treat the plus sign as real addition. This concept in computer science is called overloading or polymorphism. Overloading is making something that behaves differently depending upon the conditions it's given. So if it's given 2 numbers, the plus sign knows to add the 2 numbers. If it's given some type of text, like the word text or hello, and something else, whether it's a number or another word, it knows to concat those 2 things. In other words, just stick them together. So if I had hello plus 5 plus 3, because I'm starting with the word hello, App Inventor says, okay, we must be concating. We're not using addition as mathematical addition, and it would say hello 5, 3. It wouldn't add the 5 and the 3. To get it to add the 5 and the 3, you'd have to use some type of parentheses and file PEMDAS for it, and then it would go ahead and add that 5 and 3 for you and get 8. Or you would have to do the addition of the 5 and 3 separately and not concat it with the text. So when you're dealing with a plus sign, App Inventor actually changes what it does depending upon the values that are there. So it's really important that you do change this from whatever default value was in there to a 0. Otherwise, you will not get the behavior you want. It will not automatically start incrementing the 0 and start adding it up. It will instead just concat and put a string of 1s after whatever text was there to begin with. So the way this is actually read is that it says take the score label and assign it a new value. The value that was in there before, +1. And a lot of people get a little confused with this because mathematically this wouldn't make any sense. You can't say x equals x plus 1 in a math statement. That doesn't make any sense. But in computer science, the equal sign or the assign to symbol, where we're connecting those blocks like that, doesn't mean equals. It means assign the value to the variable. So it's okay to have the same variable on both sides of our statement, because this is really assigning this blue box into this green box. So set means change. The lighter green block score label is a get block, and get means to look into memory. So because this is a different color green, this is a get block. So we can kind of tell the difference between that. Blocks are really executed from right to left. So this does follow that PEMDAS order when you're looking at the order of operations in terms of this calculation. So now we're going to do something else. We're going to put it in an if statement. And we're going to say if the count label, I changed mine to count label for some reason. Hang on, let me see my count label. Let me pull that up. So what I want you to do is add in another label. You can put it anywhere. Remember, we're not really making an app here. We're just kind of playing around with ideas. And I want you to add in a clock timer. So I'm going to have you go into the designer and add in a label, call it count label, and add in a clock timer. And this time we're going to be subtracting 1 from the clock label. Essentially, it's going to count down for us. So you want to start it at some higher value. So maybe you want to start it at 60, have it count down, so it goes 60, 59, 58. And it's going to execute every time this timer event fires. Well, we know the timer event starts at 1,000 milliseconds, which is 1 second. So essentially, we're creating a clock timer here that will count down every 1 second. Every time the timer goes off, it's also going to check the value of the count label to see if it equals 0. If it's equal to 0, we're going to have it play a sound, and then we're going to turn the timer off. So that way it doesn't count into the negative range. So once it gets to 0, it's going to stop. So to get your sound, you're going to find your sound under media, drag that in. You can add in any sound you want for this. Buzzer sound, whatever you want. You can use a sound that we used previously. And then for the clock, that's under sensors. And you're going to drag the clock in. So you have your clock, and you have your sound, and you have your label that is going to update and count down. So put those components in. And then you're going to make it, essentially, it's going to count down from whatever number you start at. Let's say you start at 60. It will count down 1 every time. And if the counter label equals 0, then it will play whatever sound that you have stored in sound 1. You'll have to load that sound. And it will set the clock timer enabled to false. Now, one thing is that the clock timer, when this first starts, when the program first initializes, is by default set to true. So as soon as this app starts, it's going to start counting down immediately. As soon as the app starts, it counts down. So essentially what we have now is a score game where you got to click the button as many times as you can within 60 seconds. Right? And get a score as high as you can within 60 seconds. As this is counting down, the buzzer goes off, and then time's up. Okay, so one thing about the clock timer, the default clock timer interval is 1,000 milliseconds. If you wanted it to be 5 seconds, you would have to change it to 5,000 milliseconds. Now, there's two ways to do this. You can do this in code and change the timer interval property of the clock. So maybe you do it at initialization. Maybe you have, buttons that speed up the clock or slow down the clock. Or the other way of doing it is inside the properties of the clock, you set it to be whatever time you want it to go off at. We're leaving it at 1,000 because we want it to count off, by seconds, but you could change it to whatever you wanted it to. In addition, we always make it so we want to check it so it's enabled, so that way when this first starts, it will start firing immediately. So otherwise, it'll never run. It'll never count down. You could also make a button that will start the clock, and which we're actually going to end up doing in a little bit. So we're going to come back to that part. All right, moving on. So the other thing we're going to do is get a spaceship to kind of fly across the screen. A little sprite. So what I would like you to do is find some small image and create an image sprite on the screen. And we're going to get that image sprite to move in two ways. The first way is like the way we did the other day, where we had a value just added to the X value of the sprite. So you could even use the same image you used the other day. It doesn't matter what image you use. I used a spaceship. And you're going to add 5 to the X value of the ship sprite, and then you're going to assign that back to the ship sprite. And it's going to happen when another timer goes off. So you could use the same clock timer twice, but you can't use the method twice. So if you were going to combine this with the clock timer that you already have, you would have to add this line of code to the current clock timer. So to make life a little bit easier, I'm going to have you add a second clock to your code, to your designer. So you're going to go into your designer, drag over another clock. You're going to set that interval to 1,000 milliseconds. It should by default be set to that. And you're going to create a sprite, an image sprite. Not the image, it has to be the image sprite. So if we look at this in App Inventor and find it, the media, hang on, not media, drawing an animation, we want image sprite. That's what we want right there. And we're going to drag it in, and you're just going to drop it. But to do that, my fault, you need a canvas first. So you got to put a canvas first on your screen and then put the image sprite. So canvas first, size it however you want. I have actually mine pretty, height-wise pretty short, because we're only going back and forth left to right. And then I have my image sprite here, which is actually just really some type of graph picture I found. It's really not anything. And our image sprite just goes right into that canvas. And then in terms of the timer, again, that goes from sensors. You're going to find another clock timer, and you're going to drag it down here. So you should end up having 2 clock timers. One that does the countdown, and one that's going to do the clock image. So instead of labeling it clock 1, labeling this something that makes a little bit more sense would be a good idea, like clock image or clock spaceship or whatever your sprite is. Name it something that will make sense to you, so that way you know it's controlling the sprite. So go ahead and do that now. So what's interesting here is the timing. In order for the human eye to see a smooth animation, we need 25 frames per second. That's the standard frame rate for movies, 25 frames per second. Now, GoPros work at 30 frames per second. Actually, no. The GoPros work at 60 frames per second. So they get a little bit better detailed. Like your eye can see the motion better. Mostly because GoPros are people use them to slow down footage and put them in slow-mo. So if you take 60 and slow it down to 30, you get a much better picture when you're trying to do slow motion with a GoPro. But for film, it's 25 frames per second. Really, that's all you need to see a movie. So for our purposes, if we do a little bit of math here, if we take 1,000 milliseconds and assume each frame is 40 milliseconds, well, 40 goes into 1,000 25 times. So that gives us our 25 frames per second. So if you want to get your spaceship to move across the screen smoothly, rather than jumping, what we want to change our timer for our clock sprite, we want that to be 40 milliseconds rather than 1,000. Because 1,000 milliseconds means it's going to move every second. 5 blocks. That's going to be jumpy. That's not going to look like a smooth animation. We want it to be 40 milliseconds to get it to be a smooth animation. So why don't you go into the designer, click on your clock that's controlling your sprite, whatever you named it, and change the default value from 1,000 milliseconds to 40 milliseconds. Okay, so now we're going to go back to our countdown clock. Right now, the way our countdown clock works is as soon as the app starts, it starts counting down, right? Which, in terms of a game, sometimes that's a little complicated. You know, you barely realize the game has started and half your time has gone by. So it would be nice if we had a start and stop button that would start and stop our countdown clock. So we're going to make our countdown clock. We're going to go to its designer properties and make sure that its setting is disabled. So we're going to take the checkbox for our clock, for the countdown clock, and we want it so it's not enabled. We want that unchecked. Then we're going to create 2 buttons. One start button, one stop button. Put them in a horizontal arrangement if you would like, so that way they sit nicely on your screen. So you're going to have 2 buttons, a start button and a stop button. The start button will set the clock countdown timer enabled property to true. The stop button will set the time enabled property of your clock countdown timer to false. So those 2 buttons now will control the starting and stopping of the countdown timer. So that way the user can start the game and play the game. They could pause it essentially by hitting stop, and that essentially pauses it. And then they can hit start again, and it would pick right back up where it was. So that gives you the idea of how to handle a stopwatch. So why don't you go ahead and put those 2 buttons in and set the properties appropriately.